Hi everyone. Today I would like to tell about the role of MLOps. And I will start by describing one project which happened some time ago before the role of MLOps really appeared. So the company wanted to create a service which does image recognition. So the core part of the service was ML model. And to create the service and to create the ML model, company had a team of data scientists who worked hard to find a proper training algorithm, to properly prepare data set, and to build the model out of it. So after certain effort, they succeeded. So they created a good model, and this model was showing good results when doing validation and testing of it. So however, at some point they needed to go to prod, and they created API for this model and the service which provides this API, but it was quite unreliable. So, moreover, this API was not easy to consume, and the other team that was building another service on top of it, which was consuming this machine learning service, they started to complain. So, because they couldn't really create a good product out of it, and the reliability of the service was quite low. So after struggling and after some time, this data science team they have to get switched. They got switched to another project, and instead of them, a team of software engineers came. So what software engineers would do in this case, they would build a CI/CD pipeline for the service, and they will create a proper API. So it's their job; they can do it quite well, right? Uh, so they did, and the service it started to work well. But another problem happened, and the problem is that machine learning model that was a core part of the whole service, it started to perform poorly because the data has changed and the requirements from the final client has slightly changed. So what was the need is that client provided a new data set or a wider data set, and the model has to be retrained. But software engineers, first of all, it's hard task for them. So a new data scientist was added into the team, but he was lost because it was unclear what was the final state of the model, how this final model that performs well has been built, what was the data set used for it, because there were a lot of different versions of data sets stored, but which one was used, it was not known. So data scientists had to spend a lot of time to find out what was the final version, what were the hyperparameters to build those models, and only after certain effort, the team could recreate it, could retrain the model and deploy it into production. So finally, the project was successful, but the amount of time and effort spent to it was huge. But things could be different. Things could be different if from the beginning there were ML ops who would be able to create a proper ML pipeline and who would be able also to help with the service that consumes the model and with the deployment of the service and also with infrastructure behind it. Both DevOps and MLOps are very important in such projects because company requires not only a model, company requires an application that uses this model. And basically, the machine learning operation experts who work in the team, they have to be able to do both. But now I will talk more about the ML part of their scope. Because about the DevOps part, you can also watch in the video that I've uploaded before. And the MLOps part, it's a core part of it is a pipeline, ML pipeline, obviously. So why do we need ML pipeline? Uh, Despite of the obvious part that automation would save a lot of time and effort, there is another important part, which is reproducibility of experiments. In machine learning, when the model is trained, we want it to be reproducible, so that this experiment, when we run pipeline with the same set of parameters, that we get the same model, or at least of the same quality. But in machine learning, it's not so easy to achieve it, because it's not enough to have code being versioned. We also need data sets to be versioned, and also hyperparameters to be versioned. And only when we know all three versions of it, we can go and have reproducible training experience there. So in machine learning pipelines, usually everything starts from the data set. And as said, to version data set, we need data set version and system in place. And then machine learning pipeline would ingest a particular version of data and will run preprocessing. To run preprocessing, already the code is needed. Usually this code is created by data scientists, but it will be stored on source control system and will be taken out of there. So the particular version of preprocessing code is taken from there, plus the particular version of dataset. It will give some preprocessed data at the end, which can be used for training and testing. So then the training starts. Training itself, it can be quite tricky in certain aspects, and the infrastructure part of it can be tricky, because nowadays often deep models get trained. To train a deep model, we need GPU. And in certain cases, a setup of environments with GPUs, it has own complexities compared to more traditional CPU environments. But moreover, often there is a need for a distributed training, when multiple GPU instances has to run in parallel, and the training is distributed among of them. So this is also usually a part of scope of MLOps. After the model is trained and validated, it will get stored into the registry, and the model itself has to be versioned. But also important to note that as a part of training, there are hyperparameters of a training, and these hyperparameters also has to be stored along with the model. So we always know what model was trained with what kind of hyperparameters. On the next step, model will be deployed to staging, and this comes together with MLOps part plus DevOps part, because usually there's a service that also needs to go through CI/CD to pick up the model artifact, be Dockerized and deployed, and at some moment it will go to prod. But what I mentioned in the example, that the requirement, the model data sets, they tend to change over time, and at some point, usually the models, they start to perform worse, and for this, the model has to be monitored, the efficiency of the model. And when it starts to perform worse, it needs to be retrained. And again, for retraining, we can use the same pipeline, but obviously there is some work of data scientists required to identify what changes needs to be done to the original data set, maybe to hyperparameters, and etc. Maybe one last thing to add into the scope of MLOps is the work, the collaboration with data science teams. There is one interesting complexity behind it, because data scientists, they prefer interactive environments. If the development teams would usually end up with code being stored in libraries or packages, it's not the case in data science. Usually data scientists would prefer Jupyter notebooks or something similar. But the problem is that Jupyter Notebook is not something you can easily automate. You cannot just take Jupyter Notebook and run it as a part of a pipeline. Instead, there is always a need to take a code out of Jupyter Notebook and put it into libraries or packages so it can be consumed by pipelines. And this task can be done in certain cases by data scientists themselves, if they are skilled enough to do it. However, it usually still requires collaboration between MLOps and data science to identify the requirements on packages and how they can be consumed by pipelines. But I've seen also situations when data scientists do not have enough experience to build a good package or libraries that can be consumed by pipeline, and then MLOps will come into play and do it themselves. And I have outlined the main aspects of the work of MLOps, and also an important point that MLOps has a very wide scope, and usually it includes the scope of DevOps plus the scope of ML automation. Thanks for listening, and bye bye.